Okay. A symbol that represents one or more numbers is called a, somebody in class? Justin. A variable, very good. Okay, I'm going to show you two methods. I'm hoping you used what we did yesterday to complete these. We're taking, what kind of expressions are these called? Algebraic expressions. Remember, an algebraic expression has at least one variable. So these are all algebraic expressions. And when we replace the variable with a number, we then have a what? When we replace all of our variables with an assigned number, it becomes a numerical expression. Very good. Okay, so can I get a volunteer for this first problem? Bokar, thank you.
So since p equals 3, so it's 4, to make a different equation, to make it a numerical expression, 4 times 3 and 2 times.
Right, so Bokar said I'm going to make this algebraic expression into a numerical expression by replacing the variable p with the assigned value of 3. So I get 4 times 3 plus 2 times 3, and then simplify your numerical expression.
So 4 times 3 is 12.
This is 12.
And 2 times 3 is 6.
Okay, so here's what we got. 12 plus 6. And now we simplify that further, we get 18. Now, I want to talk about an alternate method because it ties to today's lesson. The lesson in connexes isn't really a lesson, so I've made this into a lesson for you guys. Okay, so watch this alternate method. The alternate method involves combining like terms, and it's very closely related. These two methods are very closely related to the distributive property, which we discussed earlier in the year. So I just want to try to get you guys ready for what we're doing in the lesson, because I feel like it's a lot to digest. So, alternate method. These are like terms, 4p and 2p, because they have the same variable. And the number in front of the variable is called the coefficient. The coefficient doesn't have to be an integer whole number. It can be a fraction. It could be a decimal, okay? And you would treat it the same way. So watch this. If I combine like terms, do you see what I did with the coefficients, the numbers in front of the variable? I can put them together. I can add them, subtract them. So I have a positive 4 and a positive 2. So 4 plus 2. And we're going to verify we get the same thing. So do you see how I got 6p from 4p plus 2p? Do you guys see that? Now if I replace this new simplified algebraic expression with p equals 3, I get p times 3. And and that becomes 6 times 3. And that gives me back 18. Isn't that what Bokar got? Yep. Okay. So often in math, you need more than one way to get there. Sometimes your two techniques, only one will work. Okay? So can I get a volunteer to explain the next problem? 5n plus 11n equals. Who's got that one? Somebody I haven't heard from yet. Zainab. Right, so you place n here, 5 times n, and that's 4. That becomes a 20, and you replace 11 times n. The n was a 4, so that gave you back 44. So let me go and walk you through that. She replaced the variables. She got her numerical expression. She simplified it. And then you have one more step. What do you get back? Okay, so alternate strategy. We have like terms, right? And when we have like terms, we can add their coefficients. So 5n plus 11n gives me back what? 16n, very good. And so this is what you should be thinking this. And then when we add that, we get 16n. Now we can change my algebraic expression to a numerical expression by substituting my variable n for 4. And 16 times 4 is going to be what?
64.
So do you see that we get the same thing back? Okay. When we go through our lesson, it's going to make sense why I'm showing you these two things. Okay, now last problem. This one's a little tricky. It threw some people off. But we're gonna substitute just like we did before. McKinley.
So you want to turn the algebraic expression to a numerical expression?
Yes, we're going to turn an algebraic expression to a numerical expression. And so what am I doing?
So first you want to change the both x's to 2.
Okay, so we have two x's here, and you're going to replace them with 2 because that's what is assigned to x. Very good.
So now you want to multiply negative 8 times 2,
Mm-hmm.
which would be negative 16.
Nice. A lot of students tripped up on that. And then what about this other term?
11 times 2, 22.
But not just any 22. That's a negative 11 times a positive 2. So that's a negative 16 minus 22. You guys got it? Or negative 22?
Answer was
Negative 30, not 36. 38. Okay, negative 38.
Oh, wait, yeah, that's it.
Okay, now let's take a look at the alternative method. Thank you, McKinley. If you look, combine like terms, you see how I'm combining my like terms? They don't always have to be positive. You still have to respect the rules of adding and subtracting positive and negative numbers. So I have a negative 8 minus 11. What's negative 8 minus 11 going to be? Negative 8 minus 11. If I'm at negative 8 and I take away 11 more, where am I at? Is it, Rehan?
Negative 19.
Negative 19. So now I have negative 19x. Negative 19x. X was 2. So twice negative 19 is going to be negative 38. Right? Because we have a negative times a positive, and different signs give you back a negative. Okay? So now this is where I feel like students start to see the repetition, and they see how they're using their skills in the back from earlier, and then it starts to make more sense to you because you're using things you learned in the past, and you see how these different areas of math kind of fit nice and neatly together, and you're using them. So let's go back to the lesson. I don't like how the book there's some terminology here, and I wanted to explain it in the warm-up, so I made that warm-up for you guys. Coefficients, you guys know what a coefficient is? Okay, and we talked about like terms. So the book does give you a definition for like terms, but didn't really explain coefficients, so I did that in the warm-up. So since this is going to be on the class YouTube channel, I'm going to go ahead and read this. What you'll learn: to apply properties of operations as strategies to add, subtract, factor, and expand linear expressions. In this case, they're talking about linear algebraic expressions with rational coefficients. So we talked about coefficients in the warm-up. So a coefficient is going to be the number that's in front of the variable. Okay? So like terms. Okay? The students this morning shared with me that you guys covered like terms last year, and it was about 50-50. Some of the students said no. Most of the students said yes, it was covered last year. I don't know if you guys got to that, but typically it is covered in the 6th grade year. You evaluate algebraic expressions by substituting values for variables. That's what we did yesterday. To simplify algebraic expressions, use properties of operations. Now, you're going to see today I'm going to bring up some of the operations of multiplication. Okay, do you guys remember the operations of multiplication? There's identity property, right? What else? The zero property, what else? The associative property, commutative property. We're going to use that quite a bit. So those are the ones I wanted to bring up. Like terms are terms that have the same variable factors. For example, 12x and 3x are like terms, but 4a and 5b are not like terms. Why is 12x plus 3x, 12x and 3x, why are those like terms? Kimberly?
Because they both have the variable x.
They have the same variable x. And why is 4a and 5b not like terms? Somebody explain that to me. Harrington, yes? They have different variables, so they're not like terms. Okay. You can use the properties of operations to order, group, and combine like terms. Now, let's go ahead and do that. So this is similar to what we did in the warm-up. I didn't tell you everything about this, but what I want you to do is I want you to take these algebraic expressions and I want you to simplify them. And most people are writing something down. There's a handful of people that are not writing anything down. I need you to write this down and try to simplify it. When you're done, if you could put your pencils down, please. Okay, I just got 2 more students that are using their pencils. Are you done, Bokar? Put your pencil down if you're done. Okay, looks like everybody's finished. McKinley, you almost done? with the first problem? Okay, good. All right, so can I get a volunteer to walk me through this? Rayhan, go ahead.
So first you have to put like the like terms like together.
Okay, I'm going to color code the like terms. Tell me, what are the like terms?
5x and 2x,
5x and 2x, and then we have something left over. What's left over?
which is 9 and negative 4.
Right, 9 and negative 4. Now, they don't have a variable, but they are like. That means you can put them together. So let me go ahead and color code it. Do you guys see how I color coded what was like? I color code the like terms, and then I color coded just the numbers, right? Now, I'm going to rearrange these. Here's what I got. Notice I kept the sign with that number or that term. Do you guys see that? So you can rearrange these if you keep the sign with it. You can't just rearrange them and not move the sign that's in front of them, okay? Now, Rayhan, what's the next step?
So then we have to like I believe solve the like terms first.
Go ahead.
So for the like terms is 5x plus 2x,
What is that?
which I believe is 7x.
Right, so 5x and 2x is 7x. What about what's left over?
So we have to subtract those.
Okay, do it.
9 minus 4 is 5.
Right, so here's our answer. Now, let me share something with you because you have a quiz on this next week. And I promise you, the answer, if this was a question on your quiz, choice number A would be 12x. And a number of students would pick that answer. And it would be wrong because they know students make that mistake. I've seen it for years. So I'm telling you right now, don't get fooled by that. These are not like terms. You don't put them together. You keep them just like that. Got it? Okay, so the answer is 7x plus 5. Okay? If you understood what I just told you, you're going to avoid missing an easy point because this stuff is easy. Okay, now, I did one problem for you or with you. Now you have to do a problem. Okay? If you do it in your head, you can forget it. If you write it down and you forget it, you can go back, look at it, and remember it. Bokar, I need you to write these problems out. I need you to work them out. You done? All 3 of them. Okay, do all 3 instead of just scribbling on your paper, please. Mr. Lopez, can you walk me through the first problem?
Okay. First thing to do is divide the terms.
And what are the like terms?
2x and 4x.
Very good. So 2x and 4x are my like terms. And then I have what's left over, right? Okay, so go ahead and combine your like terms. What's that going to be?
6x plus 3.
Very good. Anything else? Nope, that's it. This problem, if this was going to be a quiz question, choice A would be the wrong answer, 9x. Don't choose that answer. It might be A, it might be somewhere else, but this is as far as you can go. Who wants to do the next one? This one right here. Benjamin. What do you got for this problem?
I got 3y plus 7.
3y plus 7, very good. So what you did was your like terms, right? What were your like terms? Not just any 4y, it's a negative 4y, right? So if we rewrite this, this is what we got. And notice I moved the signs with them. 6 didn't have a sign in front of it, so that is a plus 6, right? Okay, and then your answer is correct, 3y plus 7. That's it. You can't combine anything else. You're done. Okay, are you guys doing all right? Everybody's getting these correct? These are pretty easy, but like I said, that's where I see a lot of students, and even high school students would make that mistake that I was talking about earlier. So I'm just trying to tell you what I've seen over the years. Okay, now this last one, there's a trick involved. Okay, and remember I told you I'm going to review some of the properties of multiplication? If you know some of the properties, you might know the trick. Goldus, can you get this one? Okay, so Goldus, what are my like terms?
R, 10R plus R.
10R and R, okay, right? And then what'd you do to fix this?
I put 10R plus 1R.
Nice. So you put a 1 in front of R, and what property of multiplication lets me put a 1 in front of R? What property of multiplication lets me multiply 1 to anything? What is it, Rehan?
Identity.
The identity property of multiplication. It says, hey, look, you can multiply 1 to anything, and it's still the same thing. So this helps us out because it kind of helps us keep track of the coefficients of a term that doesn't have a coefficient. If it doesn't have a coefficient, you could put 1 there. You could put the number 1 there. Got it? Because 1 times R is just R. Okay, now let's go ahead and simplify this. What do we got?
I got 11R minus 8.
Not minus 8. That's a minus 5 and a plus 3. So think about the number line. If I'm at negative 5, and a lot of kids have been struggling with this today, so I'm going to draw this number line. So if I'm at negative 5, okay, and I'll draw on negative 4, negative 3, negative 2, negative 1, and then here's 0. Okay. If I'm at negative 5, put it right here, and I add 3, that means I go to the right 3. 1, 2, 3. Do you see where that leaves me? Plus 2. So this is going to be 11R minus 2. So I'm at negative 2 still. You understand? Now, if you guys remember the rules, if there are different signs, you take the difference. The difference of 5 and 3 is 2. And then you keep the magnitude, you keep the sign of the larger magnitude. Which number is farther away from 0? Negative 5 or positive 3? Negative 5. So you keep the sign of negative 5, so it's negative 2. Do you guys remember that? So a lot of stuff I showed you earlier, it's coming back. You have to know it. Okay? Yep.
I don't really understand
10R, this part right here? Well, first of all, you had to identify that you had 2 like terms, and they are terms that had an R. Okay? But the catch or the trick here is this R doesn't have a number in front of it. It doesn't have a coefficient. So we put 1 there. We put 1 in front of R. You understand? Because 1 times R is R. Do you understand?
Yes, so the variable, I mean, as you can see, so the addition sign in front of the R,
Right.
we have to bring that
To the 10?
to the 10.
Well, 10, you could say 10's plus. If there's no sign, plus 10, plus 10R, plus 1R.
No, I thought you said leave your signs there, so I put 10R minus 1R.
There's no minus 1 in front of this R, so why would you put minus 1 somewhere else?
Carry the sign.
Right, that's what I was talking about. Move the sign with the number. Okay? Just like over here, that moved over here, that moved over here. Okay? That trick's going to come. You're going to have to do that a lot in algebra. Okay? So just understand that. All right. Any questions about simplifying these expressions? What kind of expressions are these? Algebraic expressions. Okay, moving right along. Now, we had this key concept earlier when we were doing mental math, but I changed it a little bit because in the past, I didn't focus so much on the algebra, but we are starting algebra. Even though it's pre-algebra, it's algebra. You could say pre-algebra, it's algebra. We're using algebra to solve these problems. So over here, I do want to show you some common errors I notice high school students would see and they get caught up on. So for distribution property, if you notice right here, I have 9, and this is really similar to what we did in the warm-up. So here's 9, and then you see 9 right here, right? That's distribution property. I'm not going to go too much into reteaching that, but I want you guys to understand what's happening to the 9, okay? I'm multiplying to each term inside of the parentheses. But here's where students really have a hard time. For some reason, they see it the second way below it, and they lose it. They forget that this is still distribution property. So if you notice, you see the 3 right here? It's distributed to everything inside still. Do you see that? And here it is again. If that is going to be a hang-up for you, then you could rewrite it. I can say that this is the same as 3 times 8 minus 2. And what property of multiplication allows me to do that? No, this is distributive property, but me rewriting it this way is something else. Commutative property. Remember commutative property? The order of multiplication doesn't matter. I could rearrange those. Does that make sense? Yep.
Which one is associative?
Associative means you move the parentheses. You change the groupings. So if you talk about people you associate, you're talking about your groups that you hang out with, right? But the grouping symbols you move. But commutative property, you're actually moving the factors around. So this would be a factor. 8 minus 2, that's a factor times the factor 3. I could change the order of those. Okay? Now, let's get to the algebra. If you look over here, I have A, and it's distributed to these terms here. But that really is no different than A distributed to these terms this way. Are we good? Any questions about distribution property? Now I want to go through this explanation down here. The book has a model to illustrate distribution property. So if you notice right here, this is just distribution property over again. And so here's 3, and here's 3. And so all it is it's taking the area of the entire rectangle. Okay. And what we're doing is we're going to multiply. How do we find the area of a rectangle? Length times width. Well, we don't know the length of this. We have pieces of the length. You see the length from here to here for the green box, right, is 5W. And we see the length of the orange box is 8, right? But if I want to know the length of the entire rectangle, what's that going to be? Think about this conceptually. How would I figure that out? What would I do? Jose? You would add. So if I add 5W and 8, what would 5W and 8 be if I took the sum of those two things? What's the algebraic expression? 5W plus 8. That is the length of this rectangle. Okay? Now, area equals length times width. Okay, well, we know my length is 5W plus 8, and my width is 3. Okay? And we already showed this above, but I'll just show it to you down here just to get that explanation in. If I distribute the 3, I end up with, well, 3 times 5W is going to be 15W. And then 3 times 8 is going to be 24. And that's the area of the entire rectangle, right? But if we look at the area right here, this box okay, 3 times 5W would be this area which I have in there is 15W, right? And then in orange over here, 8 times 3 is what? 24, which is the area of that box, right? So if we add this area plus this area, that gives me the total area, which is 15W plus 24. Okay, so I'm just trying to show you visually what's going on with distribution property. Are you going to be tested on this on Connexus, on a quiz or a test? No. It's just nice to know stuff that kind of gives you another way of looking at it. Okay, so I'm going to move on to some problems with distribution property. Can you guys go ahead and solve these expressions or simplify these expressions? Teray, can you walk me through this? What's the first thing I should do?
First you have to show the distributive property.
Right.
So you have to group. Well, you have to put 3 and in parentheses put 5W
Mm-hmm.
and plus 3 and then put the in parentheses 8
Okay.
minus 6.
Okay. So it sounds like you had this. Is this correct? This is what you have? Okay. So now we actually need to go one step further and simplify this. Can you simplify this?
3 times 5W equals 15W.
Very good.
3 times 8W equals 24 minus 6.
Right.
Which equals, well, 24 minus 6.
Okay, so very good. So let me pause you. So a number of students earlier today stopped at this point and they weren't done. They didn't recognize that they had these two numbers. They don't have a variable, but they are like their numbers. So go ahead. What's the final answer going to be?
Is 15W plus 18.
Right. Okay. Any questions? Did you guys, how many got that? Did anybody that miss it, do you understand where you went wrong? Do you need me to answer any questions about this problem? Okay. Now, I worked that one out with you. Thank you, Teray. Let's go ahead and do these 3 if you haven't already done these 3. Work these out. And the one that's a little bit of a challenge, I'd say this first one's the easiest one. This one's a little bit more difficult. The last one's a little bit more challenging just because there's some negatives in there, okay? And that does something with the signs. So be careful of that. When you're done, if you could put your pencils down. Okay, it looks like about half of you are done. Those of you that are still working, try to wrap it up. I don't think I've heard from Leah today. Leah, can you walk me through this problem?
First, I did 6 times 2x equals 12x.
Okay, and what else did you do?
And 6 times 3 equals 12.
Okay.
Just 18.
Okay, so you distributed your 6 to each term inside the parentheses. Very good. 6 times 2x you said was 12, and 6 times 3 is 18. And then what else do we have to do?
Then I did positive 18 and negative 4
Okay.
equals 14.
Right, so you took the positive 18 and the negative 4, and you got 14. That's your answer. Anybody have a question about that? We're good? What's your question?
Where did the plus come from?
For which one?
Wait, never mind.
You understand now?
Yeah.
Okay. All right. Who's going to do the next problem? Somebody I haven't heard from, hopefully. I don't think I've heard from Jose. Can you explain this one to us? Okay. You multiplied 2 times 1. What else did you multiply with 2? Not just any 8v. What kind of 8v? Right. So what did you get when you multiplied those? Mm-hmm. Right. A lot of students stopped here, but it sounds like you didn't. It sounds like you took it one more step. How'd you go from negative 16v to 21v? So you had the plus 5 and you had the 2. There's no sign in front of the 2, so what's the sign? It's a positive. So I have a positive 2 and a positive 5. Isn't that a 7? Yeah, Rehan?
For this problem, when you did like 2 parentheses 1 plus 2 parentheses negative 8b, I put 2 parentheses negative 8b first, then I did 2 negative parentheses 1. So I just switched the order, like that one was over there and that was over there. Like the last problem, I got the same exact.
Okay, be careful of that depending on your signs. If you're not moving your signs with things, then that could be a problem. Okay, that's the only thing. But you're right. I could have written, it sounds like, Jose, when you simplified your 2 and the 5, you had the number in front, right? And then, so it would have been 7 minus 16v. Now, typically in algebra, students, they like to put what they call the constants, the numbers without a variable, at the back. And they put the variables in the front, and they try to alphabetize the variables.
Yeah, that's what it is.
Does that make sense?
Yeah, the number.
So I'm just telling you, you're not wrong if you don't have it in the order, but that's the convention they usually follow. The numbers, the constants, the numbers that without a variable are at the back, and then any variables, they list alphabetically those terms. Got it? Okay. So who has this last one? Because this threw a lot of people off, this last problem right here. McKinley, run us through this really quickly. What do we got?
So 9 times 3z plus,
No, not 9.
4.
Okay.
4 times 3z plus 4 times 2.
Right. Is that what you meant?
Yes.
Okay, go ahead quickly. So what's multiplying?
4 times 3.
Not just any 4.
Negative.
It's a negative 4. So Rehan, can you wrap it up for me? Walk me through this.
So it's negative 4 times 3z, which is negative 12v.
Okay, so I'm multiplying the negative 4. I'm distributing that. And you're saying that's going to be a negative 12. And then what about negative 4 and negative 2 and positive 2?
So that's going to be negative 8.
Okay, so do you guys see how we got to this point? Okay, now we have some things we can combine. What can we combine?
We can combine.
Yeah, you have some 2 things you can put together, the 9 and the negative 8.
9 minus 8.
Right, what's that going to be?
1.
Right,
Then
there we go. That's it. Now, I want you to take a look at this last thing. I'm going to walk you through this first example. I don't need you to work it, just watch this. Look, we're going to go backwards distribution properties. So here, GCF is 2, right? Isn't 2 the largest number that goes into 4 and 14? So watch, backwards, 4x equals 2 times 2x, right? And 14 equals 2 times 7. Do you guys see that? Now, one more step backwards to distribution. Do you see how we go to that? I pulled the 2 out. Okay, do you guys understand? Yeah. Okay, can you really quickly do this one? It's pretty easy. I'm just going to go ahead and give you the GCFs of all these problems so you guys can get these done. Yep, hurry up. Do the first and the last one because of the easy ones. Really quickly so we can get this done. That's the end of the lesson. And as soon as I have a volunteer for the first one, raise your hand. Go ahead. What's the first one going to be?
I did 3, and with parentheses, inside of parentheses is 3x.
Right, so 3 times 3x. Okay, then what else?
Plus 3 times 5.
Nice. There we go. And then now we have the final step to pull the 3 out. What's that going to be?
3 and then parentheses.
3 and 3 and then parentheses and then 3x plus 5. Very good. Everybody understand that? Okay. Let's go ahead and do the last one really quick. And then if we have time, we'll do the one in the middle. Okay, who's got this one? Anybody? That's a problem. Go ahead.
Since the GNC is 4,
Right. 4 is the GNC. What do I get for my first line?
8 would be 4C.
So 4C, not 4C, 4 times something to get me 8C. What is it going to be? Right. So 4 times 2C, okay, and what's my negative 20 going to become? Not 10. 4 doesn't go into 20 10 times. Very good. So now do you guys see why we got that? The GCF, pull out a factor of 4, that's what we get. Okay, and then when I simplify, I go backwards one more step, what's it going to be?
So it would be 4,
4, and then parentheses, what's inside the parentheses? 2C
and negative 5.
plus negative 5 or minus 5. Do you guys understand? Okay, we have a little bit of time. What about this one? This was the tough one, but I gave you the GCF. Who's got this one? Justin, tell me about what's it going to be. 12. How many? What's 36 if 12 is the factor? So 12 times 3, and then 12 goes into 24t how many times? Not just 2 times, 2 what? 2t times. Okay, do you guys understand that? Now we got to pull out the 12 to do our backward step of distribution. What's it going to be for my final? 12 parentheses 3 plus 2t. Very good. And that is the end of the lesson.